Now we'll hop in. Cool. So I know it was a while back, but let's think back a little bit and see, what was the difference between inheritance in Python versus inheritance in Java? Does anybody remember how inheritance in Python worked? How did we know we were using inheritance? Does anybody remember? What do we see in our code in Python that was telling us that we'd be using inheritance? See the parent method? Close. Is it a method? It's a class. It's a class. Yeah, it's a class. So you're right, though. We would see the parent class inside of parentheses as we define our class. That's how inheritance worked in Python. How do we know we're using inheritance in Java? What are we going to see? Extends. Yeah, that extends keyword is what tells us that we're using inheritance in Java. Are there any other differences that you can think of? Use overrides. Actually, Python, you can do that too. The syntax looks a little bit different. We're going to talk about overrides, in Java. We'll see. In fact, we've already seen it, but we'll talk about it a little bit. Python, you can do that too, actually. That's the same thing. In fact, that's sort of the good thing about inheritance, and it's sort of a recurring theme for all the stuff that we've seen with Python and Java. They behave more or less the same, right? The stuff you can do with both languages is basically the same, but how you say it is what differs the most, right? Extends gets us to the same place in Java as putting that base class in parentheses did in Python. It just looks a little different, that's all. Let's talk more about the specifics of inheritance. So we've come up with some relationships. I know I've asked you these a lot, but I'm going to keep asking you them because I think they're important. So for fields inside of a class, what's the relationship? Has a, and then for methods, does a, can do, some kind of a behavior, right? It's an action. What about inheritance? What's the relationship? Is a. So the example from the prep work, I believe they used cat as the base class, as the base class. So a tiger is a cat, and a house cat is also a cat, and a lion is also a cat, right? So we can actually use that relationship in a sentence to describe, another classic example that you hear a lot when people talk about inheritance for the first time is you could have a vehicle class. Car is a vehicle, plane is a vehicle, right? Boat is a vehicle. That would be another classic use case, classic situation where we might want to use inheritance. So let's talk about why inheritance is useful, what we actually use it for. What parts of our base class? Inheritance implies that we're taking something from one place and passing it along to the next, just like an inheritance in real life, right? So what exactly are we inheriting? Methods, constructors, anything else? Setters, getters, which are actually methods, but yeah, those are included. We're missing a big chunk of classes here, actually. Fields, do we inherit those? Yeah, we sure do. We sure do. However, it's not as clear cut as that. There are access modifiers, right, that affect this inheritance process. So in fact, there's a third access modifier that was introduced. What's the third access modifier? No, we're going to see super. That's not an access modifier, though. What are some examples of access modifiers that we used last week? Private, public. There's a third one. Protected. Protected is the third one. What does protected do for us? It's kind of in the middle of public and private. If something's private, then if I'm not part of that class, I cannot access that value, period. End of story. If it's public, then it's open to everybody, right? If I'm part of the class, if I'm not part of the class, if I'm just some random guy, I can access that value, right? Protected's kind of in the middle. If I am inheriting from this class, I can still access that value. But if I'm not directly inheriting from this class, I'm not allowed to access that value. So private values, private fields, private instance variables, even if I inherit from the base class, I cannot access those private fields. Those are truly private. They are restricted to the class where they come from. Protected fields, however, are able to be accessed from any class that extends the base class. We'll actually see some examples of this a little bit later on as well. How are constructors affected by inheritance? So somebody actually kind of mentioned this before. I can access constructors from, base class, what's the class called that inherits from the base class? We have a name for that. Actually, multiple names. We have subclass, I like that name, or derived class, I'll hear a lot, right? There are other names as well. They all mean the same thing. How does the derived class, how does the subclass access constructors from the base class? Super, that's where super comes from. That's where super comes from. So, it's actually a really good idea if I'm using inheritance, if I'm creating a constructor for a subclass, to call the constructor from the base class, from the superclass. It's actually a very, very good idea, because the constructor from the base class is going to take care of initializing any of those fields that are inherited from the base class. And then I don't have to worry about those. I just have to worry about any new fields that might have been introduced in my subclasses. We'll see an example of that when we do a coding example a little bit later on too. What does it mean to override a method? So we've actually seen this in our code. We've seen this, where have we seen this before? With which methods? ToString is the one where we most commonly see it. We also saw it with equals as well. What does it actually mean? What are we doing? Why did we see the override happen with ToString and equals? Yeah.
Equals and ToString are methods of the object class,
Mm-hmm.
and you are overriding what they have in them and giving them other parameters.
Yeah, exactly. So the object class is a very important class in Java. When somebody like me says everything in Java is an object, we mean it quite literally, right? I even use the words is a in that statement, right? Every single class that you develop in Java, somewhere down the line, it may not be a direct inheritance from the object class, but somewhere down the line, if you keep following the hierarchy back up, you're going to hit object. Object is the root of all classes in Java. And so object it's actually not a particularly complicated class, right? But it does have some stuff in it, like equals and ToString, which are methods that are very useful to us. But the way that the object class implements those methods is not very useful to us. It's not specific enough. It's too general for what we need it for, usually. So that's why we often will override those methods. We'll provide our own implementations of ToString and equals that are specific to the objects that we are developing, the classes that we are writing. When we call the ToString method, it'll see that we've actually, I could use the version that I see in object, but wait, they wrote one themselves. They overwrote this method, right? So I'm going to use that version instead. That's what overriding is. Well, this can happen with other cases as well. So if I have a base class that does something in a particular way, and one of my subclasses also performs that action, but does it a little bit differently, then I can override that method and do something different with it in the subclass so that it behaves a little bit differently. Does that make sense? Are there any questions? What's an abstract class? What is that? Can't be instantiated, so that might seem a little odd, right? I can create an abstract class, but I can't actually make an object of this abstract class. So why? Why is that even a thing? Or what are the implications of that?
You can inherit a bunch of methods that a lot of different subclasses will use, but that the parent class by itself wouldn't make sense to.
Yeah, so we can still use inheritance with abstract classes. In fact, if you have an abstract class and you're not using inheritance, well, you need to rethink what you're doing, rethink your approach a little bit. Abstract classes are basically created with inheritance in mind. So the name abstract is a big clue here, right? Think about something abstract in the real world. It's something that's, I can conceptualize it in my brain, but it's hard for me to actually, make it a real physical thing in real life, right? Abstract classes are kind of the same way. I can conceptualize them in code, But to actually create one and use one usually tends to not be relevant. It's the subclasses that are more relevant in those cases. I forget what the example was from the prep work that they used. Oh, was it still cats? Okay. Yeah, okay. So you couldn't just create a generic cat. You had to create a very specific kind of cat, right? That was the implication of turning the base class into an abstract class. I could still use the things that are in the abstract class, but in order to access them, I had to use inheritance first. Are there any questions about that? That last one in particular is a pretty tricky concept for people to wrap their brains around. I gotta be honest with you, this idea of abstract classes, not something that I have even used a whole lot in my coding career. It happens. I've made abstract classes before, but if I'm talking about inheritance, most of the time it's going to be the straightforward active inheritance that you saw in the first part of the prep work. Yeah.
Can you create a class and then it just ends up being abstract because you don't ever create an instance of it?
Sure. I mean, that could happen. The question was, could you create a class and it just sort of ends up being de facto abstract because you never actually create an instance of it? Yes, that could happen. Sure. People would argue that's probably a poor design. I mean, what is an abstract class really doing? It's preventing us from doing something that we would consider to be unreasonable, right? And so if maybe you personally don't ever create an object of that particular class, but somebody else might, right? And if it's unreasonable for them to do so, then your design has failed. You should have made it abstract. Programmer, you may have noticed this in other ways. We have some programming constructs whose sole purpose in life is to prevent programmers from doing dumb things, and this could certainly fall in that category. Prevent us from doing things that are inappropriate. Great question. Any other questions? Yeah, in the back.
So, you can import one class into another one.
Mm-hmm.
There is some kind of obvious answers to this, but there are kind of generalizations about the word and patterns differences also.
Yeah, so the question was about importing versus inheritance, if I understand that correctly. So, is there a time when one is better than the other? And I think the answer is yes, absolutely. For me, personally, it all goes back to those relationships, right? If and I use those relationships very, very, very literally. I will say those out loud because to me, if I say is a, then that's boom. And it makes sense, right? If I can use that is a relationship and it makes sense, that has inheritance written all over it. And it would be foolish of me not to leverage that. Whereas what you were describing, importing a class, what does that sound like? What kind of relationship does that sound like if I'm just importing the class and using it inside of another class? It could be like has a, like there's a field. We call that composition, right? And that's perfectly valid as well. Right? It's perfectly valid as well. And we see that happen all the time. We saw that happen with, even in studio last week. With the menus that we were creating, I wanted to have dates on my menus that said when they were last modified. Date is an object, right? I wanted to use that object as part of my menu design, but I can't say date is a menu. The opposite's also false, right? Menu is not a date. Those don't make sense. Those are not factual statements. So, date is certainly part of the composition of a menu. It's a part of what a menu is, right? Which means I can import and use that object as part of my design. But inheritance is not appropriate. What are the benefits that we get from inheritance? Why should we even bother? Why not just use import all the time and just, create objects that way? What is inheritance? What are the benefits? So we can have control over, so you mentioned abstract classes and how it forces us to use the subclasses with particular characteristics. That's one example. Even if we're not using abstract classes, though, inheritance has some real advantages to it. Some real advantages.
Compatibility.
I'm sorry?
Compatibility.
Compatibility in what sense?
In that you can know that all classes that are inherent in an abstract class will work with other classes that work.
Yeah, okay. I see what you're getting at, right? So if and this goes back to what we were talking about before, what are we inheriting from the base class, right? If I inherited something from the base class, I know that all other classes that also inherit from that class have that same stuff. If this class inherits a method from the base class, then this other class is also going to inherit that same method, so I can be consistent. We actually have a computer science-y term for that. I'd call that code reuse, right? It's a big thing. Reusability. I don't have to write that same method for every single class that I have. I can write it once in the base class and then reuse that method in every class that inherits from the base class. So I don't have to write it 10 different times. I can just write it once. And if I need to change it, inheritance still provides me with the flexibility to override that method and provide a different implementation if necessary. So that's a big deal. There's another actually a big deal about inheritance that makes it super useful, perhaps my favorite example of why inheritance is useful, which is this guy right here. Polymorphism, what is that? I know it's kind of an intimidating word, but it's an important one.
That's when this object equals this object. A equals B equals C, so A equals C, or they have a relationship between them.
So there's, I can see why you would bring equality into the mix, yeah. I think it's not necessarily concerned with are the objects equal to one another though, but more how I'm actually treating them. So for example, if we use the cat's example from the prep work, if I have a tiger, right? Well, I could actually treat it as though it were just a cat because tiger inherits from cat, right? Or if I use the vehicle example, let's say I have a car class that inherits from the vehicle base class. If I wanted to, in my code, I could reference that car as not a car, but just a vehicle because car inherits from the vehicle class. In other words, polymorphism allows us to refer to an object by any of the classes in its inheritance hierarchy. I know that's a lot. That sentence was a beefy one, right? There was a lot going on in that sentence, but it's a hugely important concept, and it goes back actually to what was mentioned before about consistency, because polymorphism allows us to do things like categorize our objects into various buckets and then treat those buckets accordingly. I think it's one of these concepts that you definitely need to see in practice to really fully grasp it, but it's hugely important, yeah.
So going off the example of the prep work, say you wanted to make an array list
Mm-hmm.
with tigers and house cats.
Yes.
Would you have to initialize them all as cats?
Yeah, that's the classic example. In fact, we're going to see a very similar one. I'm glad you brought that up. So the question was, if I wanted to make an array list that had both tigers and house cats, I would create that array list with a type of cat, because tigers are cats and house cats are also cats. So if I use the base class as the type in my array list, I can put either one into that array list. I can put either one into there. There are some pros and cons of that approach, right? It's useful for a lot of things, but it also has its own little pitfalls you gotta watch out for, yeah.
Could you make an array list of objects and put whatever in there?
Yes, absolutely. You can make an array list with the type object and chuck in everything. Not primitive types, that would be the one exception, because primitive types are kind of off to the side, but anything else, yes. Create an array list of objects and throw it in. That being said, I can't remember any time that I've actually seen anybody do that. It's not while technically possible, has some very serious drawbacks. One drawback, right, is if I give you an object and I say, this is a cat, do you know if it's a tiger or a house cat? You don't have enough information to know that, right? You don't have enough information to know just based on what I told you. And if, that could be important. Whether or not it's a tiger or a house cat could make a difference in how you proceed, how you treat that object in the future. And so that's something that we need to be careful of when we're using polymorphism. All right, cool. Another piece that was part of the prep work today was class diagrams. So this is another hugely important aspect of design. We spent a lot of time actually talking about design in the last couple weeks. And so class diagrams are, ways that we physically design our objects and also their relationships to each other. So now that we've talked about inheritance, we can talk about relationships between objects. So what am I going to see in a class diagram? Obviously, I'll see classes. What goes inside of the classes? The name, fields, methods. What other information? There's one other piece of information. Getters and setters are methods, but yes. Although a lot of times, honestly, I tend to leave those off because getters and setters are usually straightforward enough that they're not important to the design necessarily. But you can include them, no harm. We also include access modifiers, right? Access modifiers. So is it public or private? We usually use plus or minus to accomplish that, but that's not the only way you'll see people do it. You'll see people use various things to reference the access modifier for those values. And then we can have relationships between classes. So we've talked about inheritance, which is a relationship between classes. How does that show up on a UML diagram? It's an arrow. Specifically, though, UML is very, 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 very explicit about every little detail. Specifically, it's an arrow where the head of the arrow is not filled in. I know it seems like I'm splitting hairs there, but that actually is the full official definition. And it makes a difference because there is an arrow that is filled in that means something else. What's another kind of relationship that you might see on a class diagram besides inheritance? I'm sorry? A hazo. So the name for that would be composition, right? This is part of this class. How is that going to show up? How's that relationship going to show up? Anybody know? The diamond? Yeah, I think diamond is for aggregation. I'm sorry? Has many? Aggregation? Yeah. So if I had a whole bunch of those things, that would be a diamond.
A straight line without.
Straight line, I think, yeah. I think it's just a line connecting the two. And that's just a small example. The UML specification is actually rather large. You can buy a book that's got the UML specification in it. It's not a huge book, but it's also not a very fun book to read, cover to cover. I don't recommend that at all, but it is a good reference book to have around if you're doing a lot of design-oriented activities. In fact, that's what we're going to do right now. We're going to do a design activity, and then we're going to turn our design into some code in a little bit. So let's switch over. A lot of the examples in the prep work were done on paper. You see they actually look like hand-drawn diagrams, right? And I'm still a big fan of doing things that way. It's just hard for me to do it that way when I'm standing up here in front of all these people. So instead, I'm going to do it online, and I'll show you this tool that I like to use if I'm going to do this on the computer. It's a website called draw.io that's just extremely useful for making all kinds of diagrams. I primarily use it for this, UML diagrams. It's great for that, but it's good for other things as well if you need to make flowcharts or other kind of charts. It does a lot of cool stuff, and it's free as far as I know. So what I want to do, you'll recall from last Thursday, that we made a class. We made this bank account class, right? First thing I want to do is document this. I want to create a UML diagram to represent this class. And then we're going to add some more stuff to it after that, and we'll code it up. That's the idea. So let's start with this. Start with this guy here. I need to find the UML diagram for a class. So here it is. Take this and drop it out here. Class name is bank account. And now I can type in my fields. Right? Oh, come on. So, go take a look. I've got two fields, an account ID and a balance. So I'll put those on my diagram. They're both private. This is one thing that drives me crazy every time I use this tool. They have a plus here, which stands for public field, and I'm just a very firm believer in public fields being a huge no-no, a huge bad idea. So my fields for my class is always going to start with minus sign, because they'll be private. So we've got an account ID. And actually, for some people, this is enough for listing fields. Other people want to see the type there as well, so if you can put the type after it if you want to. UML, like many things in life, has, while clearly defined, has an official specification. People have their own spins on it, their own interpretations on it. So I have an account ID, and I also have, what was the other one? A balance, which is a double. And I need to resize this guy here a little bit, if I can, please. Maybe? Oh, come on, what are you doing to me? There we go. No, there we don't go. What did I do to deserve this, computer? Draw.io. Yeah, I don't know why it's covering up my text like that. That's annoying. Oh, I see what you're saying. So like this. Yep, that's what I did wrong. Thank you. I was doing the wrong thing. Oh my gosh. Please. Please. You know what? I'm just gonna leave it. It's fine. It's okay. All right. Sorry. Whoa. Yeah, never mind. I'm not gonna, yeah, I don't want to spend all day dragging lines around. That's not the point of this exercise. Okay, so that does it for our fields, and then we can also take a look at what methods. That's the next part, right? Constructors. Do I want to put constructors on here too? Sure, why not? No reason not to. So let's stick them on there. So I have two constructors actually, and with constructors you'll often see, again, this is one of those things that can kind of vary a little bit. Some people like to put the parameters to the methods in there. Some people, a little bit more loosey-goosey might leave the parameters off of their design. It really depends on how detailed you want to go with it, but if you're going to put the parameters in, often you don't need to put the names of the parameters in. You'll just put the types of the parameters in. So the type of this was int double. And then I forgot to put the access modifier, which was plus. And I had another one that was just an int. Come on now. I'm really struggling with this program today. And what other methods do I have? Deposit and withdraw, both taking a double in. Now these have return types associated with them, so we'd probably want to include that as well. So we'd have plus, deposit, double, plus, withdraw. And I know my text box is off here. I can fix that, maybe. Hopefully. There we go. Much better. Am I missing any? Oh yeah, we did. So getters, right? Some people like to put getters on there. Other people, getters are usually pretty straightforward. There's not a whole lot going on here, right? I oftentimes don't feel too bad leaving the getters off of my UML. But if you feel it's important, you certainly can include them. ToString and equals are other methods that are so common that you might see them omitted from an official UML diagram. Depends on the level of completeness that you're going for. If you feel strongly about including them, you certainly could. Main method you typically would not include on a UML diagram, however. So honestly, if you wanted to stop here, you could. I would be all right with this design. If somebody handed me this design for the class that we made, I would be okay with that. If you're looking for something a little bit more formal, a little bit more complete, you're certainly welcome to add the getters and toString and equals and all that business onto this design. Are there any questions so far? Yeah, what's up? Yes. Oh, okay. So Yeah, actually, so these methods are what I was referring to with overriding. You can clearly see that they're marked as such. But what you're referring to up here with like the, I didn't type the name of the constructor in correctly. Anyway, what you're referring to is this, right? How I have two different constructors? I would call that overloading, which is, I know is very, very similar to overriding, but technically a little bit different. Overloading is when I have two methods with the same name in the same class. Subtle difference there, but let me correct this because I don't know why. Oh my gosh. Let me correct this. I don't know why I called it just a bank instead of a bank account. All right. So what I want to do next is add some stuff to this design. This is really going to bother me, but oh my gosh. Keeps getting worse. What I want to do next is add some stuff to this design. So we have a bank account class, and I feel like it works pretty well. There's more stuff that we certainly could do with it, but not all bank accounts are created equal, right? There are different kinds of bank accounts. So, you know, a lot of us probably have a checking account, and there's probably also a savings account, right? And they have different purposes, and there's other types of accounts as well. I'm actually not familiar with a huge amount of stuff in the banking world, but I have a checking account and a savings account, right? I feel like it's a pretty standard setup for a lot of people, right? And so, you know, checking accounts, a lot of times they might charge a fee, or they might do overdraft protection or things like that on your checking account. Whereas savings accounts, the advantage of having a savings account is that you're likely to get maybe a little bit better interest rate on money that's stored in that account. And they'll compound that interest rate every so often, and you know, you'll actually earn a little bit of money based on how much money you have in the bank. Those are the two primary differences. I would like to try and capture those differences in my design. So what I'd like to do is add checking accounts and savings accounts to this design. Think about what the differences are between those two things and what we already have, and then code it up. That's my plan. So we are gonna, you can probably already kind of tell where we're going with this. I'm gonna need 2 more classes, 1 for each. So I'll drop those in, see if I can get them both on the same screen. That would be ideal. What's the relationship between these 2 classes and bank account? It's going to be inheritance. Checking account is a bank account, right? That makes sense. That is the thing that makes sense. Checking account. And the savings account is a bank account. So I want to use inheritance, and this tool does have inheritance right here. They call it generalization. That's the UML official name for what this means. You can see it has the word extends, right? Well, maybe you can't. It's really super small text from where you're sitting probably, but it does have the word extends right there as part of the definition. Now you can see it. And so we'll draw this in and hook it up. Hook it up to these guys here. That's a very tiny arrow all of a sudden, but oops, that's the wrong one, sorry. This one. All right. There we go. I missed. There we go, that's better. Close enough. So now we see, if I can zoom out a little bit. Nope, wrong direction. Nope, too much. Okay. Now we can see that we've got 2 classes, checking account and savings account, that are both going to inherit from this base bank account class. And so what we need to do then is think about, okay, we need to design these objects, right? Anything that's already part of our bank account class, we don't need to include in these classes because we're using inheritance. It's already implied that these 2 types here will have an account ID and a balance associated with them because they're using inheritance. Is that right? Is that a true statement? Yes. Okay. So what might be some differences? Can you think of a field that might be different for a checking account? A fee, yeah, that's the one I was thinking of. So I might include a field called a fee. And that's probably going to have a type of a double, right? And then the method, can you think of any behaviors that might be different? So overdrafts is a thing. So overdrafts happen when I withdraw funds, right? So actually, that might be a case for overriding the withdrawal method in a checking account class to check for overdrafts, allow for some protection. I think that's useful. Something that we can do that might be a little bit different as well is to just have a method that can, actually charge the fees, right? Compute the fees and deduct them. So, charge fees. I don't think we need any parameters for that method. I don't think we need a return type for that method. Could argue that it should be public. Could also argue that it could be private, either way. Are there other differences? Probably, almost certainly, but for the sake of this example, we're just gonna do this, and then let's see if we can think of, so what might I do for a savings account? Let's do interest rate. So I'll have a field, which is probably also gonna be a double, right? It's usually some kind of a percentage. And then the method along these lines would be compound interest, right? Does this make sense to everybody? It's a small design, it's a simple design, that's intentional because I do want to focus a lot more on the inheritance piece, but are there any questions about this design before we try to implement it? All right, let's take a stab at it. I want to create both of these classes and actually implement the stuff that we talked about. So I'm going to go back over to IntelliJ. I'm going to create a new class. I'm actually going to create 2 new classes before we're done here. We'll go ahead and start with the checking account. So here's my checking account class. How do I do the actual inheritance? Extends bank account. That's where it comes from. So what should I put in here first?
Is it going to matter the file structure since it looks like you created checking account in a subfolder?
Did I put it in the wrong thing? I did. I didn't mean to put it in there. I meant to put it in here. Thank you. Quick drag and drop will fix that for me, I hope. Okay. So what should I do first? What's the first thing you usually see when you're writing classes? Fields. So we had one from our design. It was called fee, right? Fee, and it was a double. So we'll stick it in. Private, double, fee. There were no other fields listed on our design, right? We did kind of forget something here, though. The next thing that I want to put in here is probably what? A constructor, and I didn't actually include the constructors here on my design. That's something that I should probably rectify. So, I can come in here and add a couple constructors to this list. The order does kind of matter. You do want to try and keep things somewhat organized. What do you think are we gonna have input parameters here? What do we think? Yeah, the fee, right? So that'll be a double. Now I gotta resize these text boxes again. Wish me luck. Maybe. Yet to be seen. Oh, hey. All right. If you're watching this on YouTube, don't forget to hit that like button. We'll add a constructor for the savings account as well. And like we did with the checking account, the input parameter here is probably going to be the interest rate, double. I can't wait for this video to have more likes than any of my other videos. All right. Cool. We updated our design a little bit. Looks a little bit better now. Let's get back to the actual coding piece. I want to create that constructor, so I'll go ahead and do that. Oops. We said it was going to take in a double, probably called fee, or if you want to call it something different, you can. What should I do inside this constructor? I should assign the fee to the fee. I actually like to do something else first. We do need to do that. But I like to call super. Somebody mentioned this. I like to call super, right? Hold on, but wait a second. You can see IntelliJ is mad at me, right? Cannot resolve method super. And if I click this, you can see it doesn't know what I'm talking about. Why not? Super is what? What is super referring to? It's referring to the base class, specifically the constructor of the base class. So if I go back to my base class, right, and I look at that, you can see I do have constructors available, but wait a second. These constructors take in parameters, right? And I can't just skip out on those. I still need to have those pieces of information. I still need to have an ID and a balance, or at least an ID, right? Still got to have that information. So what does that mean about our design for the checking account? Do I need more fields?
To initialize some kind of variable to pass it in.
I don't actually need more fields, but I do need more parameters to my constructor. That's the solution to this problem. Specifically, I need an ID. At the very least, I could stop here. But you know, I could also put in a balance as well. And now when I call super, I can plug in ID and balance. And you can see that it's happy with me now. Let's take a second and think about what's actually happening here, because this is a very important concept, right? When I create a checking account, I still have to tell you what the account number is and what the balance is. I'm passing those to the superclass, which is quite literally the constructor, this constructor right here. This is the constructor that I am now calling. And so it is going to take care of assigning values to account ID and balance. Those values are going to get set through this call to super. So those are no longer my responsibility. I'm just responsible for whatever's left, which is the fee. That's what the checking account is now responsible for. And we can just set that in the way that we've been doing it, right? So remember what's a constructor's job? A constructor has one job. Make sure all the fields have values. Have we accomplished that? Yes. Super takes care of any fields from the base class. We've taken care of any additional fields that we have ourselves. Does that make sense? That's why I like doing super first, get those out of the way, and then clean up anything extra that's left over. Does that make sense? Are there any questions? It's an important concept. All right. You know, we should also update our design to reflect this, and you can see that we're going to run into the same problem with the savings account as well. When we get around to doing that, which is going to happen soon. And my text box is now far too wide. This is great. I'm going to have to reorganize a little bit here. I can do it though. I can make it all fit. Just widen this a little bit. Oh, careful. There we go. I think that'll do it. Let's see. Hey. No, I want the whole thing. There we go. Perfect. All right. We got it. Great. So now I just need to do the last piece, which is charge fees. I got the constructor, I got the field, I just need to write this charge fees method. So let's do that. You might be wondering, well, where did you just get public void from? Did you just spit that out? Well, no. I mean, kind of, but no. It's part of the design, right? I don't see a return type here. Or if you really wanted to be super explicit about it, you could put the return type out here, void. If I don't see a return type, then I'm just going to assume that it's void. But if you really want to be explicit about it, you could stick the return type out here as void. And the plus tells me that it's public. So I didn't just pull that stuff out. It's on my design. That's the nice thing about having a design. If you spend some time thinking about your design and documenting your design, when you sit down to write code, you don't have to think very hard about it at all. You just have to follow your design. You just have to do what your design's telling you to do. You've already done a lot of the heavy lifting. All right, so we want to make this charge fees method. And I think it's this is a pretty simple method, right? It's just gonna probably just take the phi away from the balance. It doesn't need to be super complicated. So how do I access the balance? What do I say? This dot balance, oops, equals this dot balance minus this dot phi. So this seems reasonable. I don't think I did anything too crazy here, but IntelliJ's mad at me. Why? I'm sorry? Balance is private. Why is that a problem? This is a subclass. Private is very, 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 very restricted. If something's marked private, anything outside of that class cannot touch it. Cannot touch it, even if we're using inheritance. So how do I fix this problem? We're gonna go make it protected. And you might be asking yourself, all right, should we make account ID protected as well? And you know, the answer to that could very well be yes. I think you could make an argument for that, right? But based on the design that we have right now, I would strongly argue that the answer is no. We're not directly doing anything with the account ID in this checking account class or any other subclasses, right? I want to keep that access modifier as strict as possible, as strict as possible. So if some point down the road my design requires me to access the account ID for some reason, okay, I might want to change that field to be protected at that point in time. But unless I have a reason to do so, I'm going to leave that field marked private. Until I have a reason to use that value in my subclasses, I'm just going to leave it marked private.
For our design, we had it marked as private. Is there a special symbol like plus minus circle?
Great question. Great question. So how do we mark inheritance, or I'm sorry, protected in the UML diagram? Let's see. I actually don't remember off the top of my head. I'm almost positive there is a way to do it, but
Is it 2 dashes?
I think it's it looks like it's this guy. Yes. Pound sign. This guy grew up in an age before Twitter. I did as well. So now balance will mark as protected like so. So far so good? Any questions? So, I mean, we made it through checking account, and you can kind of see how a savings account would follow a very similar trajectory, right? I actually kind of want to do this because I want to show you an example of polymorphism. I think that's really important, and in order to do that, I need 2 classes with inheritance. But since we've already done this once and it's very similar, I might blow through this one a little bit more quickly. So if I'm going too fast, definitely holler at me. I'm of course happy to share this code with you as well afterwards, but I'm going to move through the savings account one a little bit more rapidly because we already kind of have an idea of what that's going to do for us. All right, we're just going to follow our design. This had a field called interest rate, right? We also had a constructor, and you can see that our constructor had an int and 2 doubles associated with it, just like our checking account did. Int account ID, double. This would be the balance, and then the next one would be the interest rate. We're going to call super, just like we did before, pass in the account ID and the balance, and then we're just left with the remaining field, which is interest rate. Oops. Oh, I forgot one very important thing, didn't I?
Didn't extend it.
Yeah. I was wondering why it was mad at me. It had a very good reason to be mad at me about that. What constructor was it trying to call before I put that extension statement in there? Object. Yeah, it's trying to call objects constructor, and it didn't know what the hell I was trying to do. I had no idea. All right. This dot interest rate equals interest rate. And then we just had to put in that method, void, what did I call it? Compound interest, I think. I actually might need you guys' help with this one. This dot balance, is it just equals, I guess I'm not worried about how the bank might actually do this. Plus times the interest rate, yeah, that's what I was gonna do. Something like that seems reasonable. I'm not worried about the math. The math is not the important part of this exercise. You could just set the balance to the number 7 for all I care. It's not an important part of this. But now I have two classes that both inherit from this bank account class, which is important for polymorphism, which is I think the last thing I want to show you today. All right, let's talk about polymorphism. In fact, I want to do an example that's very similar to what somebody asked me about. I'm going to come down here and create a little main method. And what I want to do, I actually want to do the exact example that was given to me during the review session. I'm going to create an account of each type, a savings account and a checking account. I could even create an account that's just the base class as well, the bank account class, right? So I can create a bank account. I need to bank account base, new bank account, pass in, you know, balance, checking account, checking equals new checking account, and then this needs an ID, a balance, and a fee amount, which we'll just say is like $5, and then a savings account. Keep putting too many parentheses. Balance, and an interest rate, which is probably going to be a number between 0 and 1, right? Actually, savings account interest rates are really, really, really low. Yeah, so like, I don't know, 1%, which is extremely, that might even be higher than most savings accounts actually these days. Savings accounts do not have a great rate of return. But for our purposes, that's fine. So, I know I went through that a little bit quickly, but what I did, I just created 3 instances, right? One of the base class, one of each of the derived classes, and to show you what we can do with this, let's make an array list of bank accounts. Actually, yeah, like that. I need to import it. And now because I used bank account as the type of this array list, I can actually add all of these guys into this array list. I can say accounts.add base. It's perfectly happy with that. Accounts.add checking. Perfectly happy with that. Accounts.add savings. Perfectly happy with that as well. No problems. So I have 3 accounts. You can clearly see they have different types. I declared them with different types, right? But I stuck them all in the same array list. So I was able to categorize them all by the base class. And so why is this useful? What does this allow me to do? Well, let's say I wanted to iterate through this. Let's say the bank's feeling generous, right? And they want to just give everybody an extra $500. That'll never happen, but you know, for the sake of argument. I'm sorry? Pass to go, yeah. That's only $200. Yeah. So if I wanted to, right? I could do something like this. bank account B, or actually I could have used an enhanced for loop here if I wanted to as well. That might have been a little bit easier, but I'm already down this road, so I'm just going to keep following it. Oops. Get the bank account out of the list, and now because I know it's a bank account, I have access to all of the methods that are in that base class, right? All of them. And so I can call deposit and stick in $500. It doesn't care whether it's a checking account, a savings account, or a bank account, because checking account and savings account both inherit from the bank account class. It knows that that deposit method is going to be available. What if I wanted to compute fees on this guy? Could I do that? With an if statement within my loop. So the question is, right, can I somehow look at this bank account B and figure out if it's actually a checking account or if it's actually a savings account? The answer to that question is actually yes, there is a way to do it. However, good design says that if you're asking that question, you probably took a wrong turn somewhere. Good design states that, you know, if you really are trying to figure out what the actual type of something is, you're probably a little bit too general when referring to that object. If I really care about the fees associated with a checking account, then maybe I shouldn't be putting checking accounts into this general bank account list in the first place. Maybe that's a bad idea. But you can, I think it's worth mentioning that you can cast things. So if I wanted to, this is a perfectly legal thing for me to say. I can cast them into a checking account, right? I can cast this bank account B into a checking account. Actually, I should say it more like this. There we go. What's the problem with this? So if I get a bank account or a savings account instead, boop, it's over, right? Program crashed. It's no good. So if I'm gonna cast something like this, I better be darn sure that that's what it is. This is a perfectly acceptable thing to do. It is totally okay, and in fact fairly common for me to cast something based on inheritance, right? Perfectly acceptable, happens all the time. You better be darn sure that that's what it is. And again, if you don't know what it is, and you feel like, well, I really want to cast this thing, make it into a savings account or whatever, but you're just not sure that that's in fact what it is, you took a wrong turn somewhere with your design. You made things too general, right? Maybe an array list of bank accounts. Just because I can do this doesn't mean that it's the right thing to do. Maybe I took a wrong turn somewhere, and I should have kept an array list of checking accounts instead, or savings accounts instead, right? That's what that means. So really, as program designers, these are the kinds of things you need to worry about now. Polymorphism, hugely powerful tool. Being able to do something like this, incredibly powerful, incredibly useful. I hope you can see the usage of this, but you do have to be very careful about how you approach this. It is very easy to paint yourself into a corner. What questions do you have? Yes?
Back up and explain what you mean by casting.
By casting? So what is casting? I know we've seen casting very briefly before. We haven't spent a ton of time on it. What does it mean when I cast something? What am I doing? Changing the type. That's what it is, changing it from one type to the other. In this case, we're changing the type from bank account into checking account, or we're attempting to do that. It would work for this guy. It would not work for either of the other two, which is why this statement right here is a bad idea. Do not do this. In fact, before I post this to you all, I'm going to comment this out and be like, can't do this. Add cast. Casting in general, though, is very useful. This is a bad example of casting, but casting in general, very useful, very acceptable. No problems with doing that. Very happy about it. Someday, you'll probably run into this problem, and I'm sure you'll Google, how do I figure out what the actual type of this thing is? I've been down that hole, right? It happens. And you'll actually find answers. You'll actually find people on Stack Overflow that say, you can do this kind of thing. But then keep reading the lower posts on Stack Overflow, because you'll also find people on there saying, you shouldn't do this. This is not a thing you should be doing. Just because you can doesn't necessarily mean you should. There are always exceptions, but in general, you should think long and hard about that before you actually do it. What other questions do you have? Any other questions? Yes?
Would polymorphism work with an abstract class?
With an abstract class? I actually believe that it would, yes. An abstract class? I cannot instantiate a new object with the type of an abstract class, but I can still use polymorphism with that abstract class. So in other words, really what I mean when I say I can't instantiate means that I can't use that new keyword, right, with an abstract class. There's no constructor, in other words. Abstract classes don't need to worry about constructors because you cannot actually create them. However, I can still use polymorphism with them. I mean, that's such a strong strength of inheritance that it would be very detrimental to take that away. And we'll actually see, you can actually see polymorphism show up in other things as well. There's something that we haven't talked about yet, but we might talk about in the future called an interface that polymorphism works with as well. It's just a hugely powerful and common tool. What other questions do you have? Great questions. Yes?
How does one know when to use getters and setters?
How does one know when to use getters and setters? So, do you mean when to write getters and setters or when to actually use getters and setters?
Use them in the code.
Use them in the code? So, if I'm inside of a class, right? Like balance, we have a getter for balance. I could have used get balance here if I wanted to. I totally could have. And that might have been okay. In fact, it would have done exactly the same thing. We would have made it to exactly the same place, right? But if I'm inside of a class that has this field, or in this case, a subclass that has access to this field, I prefer to usually just access it directly and do what I want to. For other classes on the outside, they can't do that. Remember, this variable is marked as private. They cannot access this variable directly. The only way that they have to access the balance is through the getter and setter. So they're required to use getters and setters if they want to know what the value of that variable is. But if I'm inside of the class or a subclass and I have access to modify that instance variable directly, that's usually what I prefer. There are always exceptions, but in general, that's usually what I prefer to do. I mean, that being said, if you did this, if you use get balance instead, I wouldn't be unhappy with that at all. It's totally fine. What other questions do you have? Yes?
If you do a bad cast, what happens? Like, does your computer like shut down?
It's an error, yeah. I mean, you're not going to fry your motherboard or anything, but yeah, it's a runtime error. Your program will crash. Yep. And it'll bring everything to a screeching halt.
So would it be like a while loop that never finishes? It just kind of
Well, so a while loop that never finishes is not actually, so it's not an actual error. It's an error in logic, perhaps. Although sometimes we actually write infinite while loops intentionally. But this would actually give you the red text at the bottom of the screen that says, I mean, I could run this actually and just show you. Why don't I just shut up and run the code and show you? I wrote bad code. Let's do it. Run this guy. Boom.
Okay.
We got an exception. It is a cannot be cast. Yeah. What is it? A class cast exception? Yeah, class cast exception. Tried to cast it to this thing, but it couldn't. You know, when I write the code, before I try to run it, IntelliJ looks at this and says, well, that seems like a reasonable thing to do, right? It doesn't know what kinds of stuff I put in the list. It has no idea until I actually run it and it tries to do it, and then it's like, oh, can't do that. It's like if somebody gave you directions to get to the grocery store or something, and they're like, take a left at this point in time, and then you start driving and you get there and you're like, oh, this is a T intersection. If I take a left, I end up in that guy's front yard, right? That's what we did. We ended up in some guy's front yard. Got bad instructions. They seemed reasonable before we left, but when we actually got there and tried to do the thing, we realized they were bad. That's what just happened. What other questions do you have? Yes?
Look at the Y of the override annotation.
The override, yeah, sure. In fact, we mentioned that override might be useful for a checking account. I guess we could take a look at that and see. So if we wanted to, with a checking account, what that really means, let's take a look at our original method for withdrawing. You can see that here, withdrawal says we have to have enough money in our account, right? I can't take my account into the negative. That's not allowed, right? With a checking account, if you have overdraft protection, you actually can take your account into the negative a little bit. It won't let you like drive it deep into the red, but if you go like 20 bucks over, right, they're just like, oh, okay, right, that might work. So we could write a method that would override this method inside of our checking account. Let's say that we just want to allow them to go a little bit below zero. Not a lot, but a little bit below zero. So what I would do is start writing the method withdraw. And I'll have double amounts. You can see that IntelliJ has recognized, actually, do we have a return type? Oh, we did, double. Sorry about that. Double. And you can see that IntelliJ has kind of recognized what we're trying to do here. You see it's got this blue circle out here. It says overrides method, right? Yes, that is true. It overrides this method right here. And really, we should mark that by putting the override annotation in front so that it knows that. And now we can define this method however we want. However we want. We can do whatever we want with this. So we said we wanted to allow, you know, I think it would behave very similarly to this, right? Amount is less than this dot balance. Well, okay, if amount is greater than 0 and amount is less than this dot balance plus $20, right? I can go $20 over what I have in my account and still be okay, right? Then do the withdrawal. Brackets, please. All right. Equals this dot balance minus amount. And then, so literally the only difference between this method and the one that we had here is that we just have a little bit of a threshold, right? Just have a little bit of an extra threshold there in terms of what we can do with our withdrawals. I know this isn't exactly how overdrafting works, but you know, I'm just trying to keep it simple. And so now, actually, if we return to here, right? Our example using the list of bank accounts, and I say if I were to say withdraw here, what would happen when it got here? It's kind of a strange situation, right? I don't know, I can't tell just by looking at the thing that it's actually a checking account. But when I actually call the method on it, it's going to see that it's a checking account. It's going to see that checking account has overridden the withdraw method, and that's the version that it's going to use. It's going to use the version that's in the subclass, not the base class. Yeah.
The bank account gets added into the array list. It remembers what it was before or when it jumped in, so it knows in memory. This is a checking account. This is the same.
Yes. I don't want to get too much into the nitty-gritty details about how this stuff works, but yes, the computer does know the actual types of these things. I'm sorry? No, the computer definitely knows that this thing is a checking account, right? We as programmers can't necessarily figure that out. We can, there is a way, right? I've made that clear, but we as programmers don't immediately know what the type of this thing is, but the computer does. And the computer will find that this method that's been overridden and use that method. Now, one other thing that I'd like to show you about overriding methods, it's actually pretty similar to what we saw with the constructors. Maybe the method in the base class works pretty well. You just wanted to do something a little bit extra, right? I want to do whatever's in the base class and then just add a little bit extra onto that. Well, just like we saw here, With the constructor, I can do something kind of similar with my overrides as well. I can say super dot withdraw. This will call the withdraw method from the base class and do that first. And then I can do whatever extra stuff I wanted to do afterwards. I don't think that applies to this particular situation. It doesn't make any sense for me to do this here. This isn't the best example for that. But there are other cases where you find yourself in a situation where the base class is like 90% of what I want to do, but then I just wanted to add a little bit of extra on, in which case I don't have to rewrite all that code. I can actually call that method directly and then do any extra stuff that I wanted to do using this super keyword. So super is useful not just in the constructor, that's where you'll see it most often, but you can access any methods from the base class using super in your code. What other questions did you have? Any other questions? I know this is tricky stuff. You guys seem to be picking it up though. Great questions. Yeah.
Intentionally not inherit a method?
Can you not inherit a method? That's not possible. No, if I'm using inheritance, I get it. It's all or nothing, right? It's all or nothing. So it's going to be there. Now, if a method's marked private, right, I can't actually use that method inside of a subclass, or just like a field, if a field's marked private, I can't access that field in the subclass. But it's still there. You cannot pick and choose what things are inherited though. If you are in a situation where you want to use inheritance, but you're like, well, this method, though, doesn't really make any sense. I don't think it should be included in the subclass. Well, hate to break it to you, but maybe you shouldn't be using inheritance then. That's an indication that inheritance is probably not the right way to go. And that you're potentially breaking that is a relationship that I would expect. Yes?
Could you override a field?
Could you override a field?
Like, if you say you wanted to like change the type that was the field.
No, you can't change the type. Yeah, it's similar to methods. It's an all or nothing deal. You get all of it. If I use extends and I inherit, I get it all. It's all there. Yeah.
You put the field in the inherited class, I think, in the prep word.
Maybe I misunderstood the question.
You don't change the type, you just change what equals.
I'm sorry?
Like in the prep word,
Well, you can change the value. Yes, you can change the values of the fields. In fact, I mean, we did that here, right? Here's a field from the base class. You can change the values as long as they have a protected type or a public type, but they shouldn't have a public type. As long as they're protected, yes, you can do that. But I don't think I would be able to do something like this where I change balance into an integer. Well, it's not mad at me. Maybe I'm wrong. Maybe it is gonna let me do that. Will it run the thing?
Still have the other thing.
Well, yeah. Well, now you can see now it's just mad that this is a double. Actually, maybe I'm wrong, because it seems to actually be letting me do this, which is a little surprising to me. Yeah, okay. I stand corrected. It let me do it. So yes, you can override it. Apparently. It let me. That's interesting. Okay. Great question. Obviously, by the way that I'm talking about it, you can tell that I haven't done that very much, if ever. But yeah, good to know that it's possible. What other questions do you have? All right. If there aren't any questions, we'll go ahead and wrap up the review session. We do have a studio today that's based on inheritance. If you want to work on, excuse me, if you want to work on the assignment, you can have some time to do that as well. Unfortunately, we are a little short on TAs today. I think we're down 4 TAs today, so I apologize about that. It's not ideal, we know that, but we are going to try and make sure that everybody gets the help that they need. So be patient. We are going to get to you. We will answer your questions. We will help you out. Just might take us a minute or two longer. Thanks.